Hello, my name is Ashton Jakubiak. Today I will be covering the comparisons of carbon fiber PLA, a composite, to standard PLA, its matrix, using 3D printing to provide an insight to their properties. So, what's a composite? A composite is made of two or more materials. Usually, one material serves as the matrix phase, and the rest of the materials serve as part of the reinforcing phase. Some common types of materials that you might find as composites are things like fiberglass, which is a combination of glass and resin, reinforced concrete, a combination of course, concrete and rebar. Polylactic acid, or PLA, serves as the matrix phase for the carbon fiber PLA. Polylactic acid serves as a biodegradable polymer alternative to plastics formed by non-renewable resources. Our composite for this case, carbon fiber PLA, is a combination between carbon fibers, which have a great resistance to deformation, greater than that of steel, though it is also very brittle and is often found in a powder-like form. Combined with PLA is a lightweight, durable, and flexible material. For the beginnings of 3D printing, Hideo Kodama came up with the first 3D printer prototype, which involved the use of a UV laser pointed into a pool of liquid resin, causing parts of the resin to solidify and layer into a print. The type of 3D printer used in this project, however, was a very different kind than Hideo Kodama's. It did use the layering method, though it was not done by a laser, but by heating up the tip of the nozzle where the filament would come out, melt, and create layering for the model to develop through. And this model is much like the Darwin model, which was first commercially available back in 2007, one of the first 3D printers on the market. The method by which the carbon fiber PLA and standard PLA were compared to each other was by creating several models without supports, by which the successful and unsuccessful parts of the model would be noted. Now, the importance of these supports was the fact that without them, it is a lot harder to create a model that is computer perfect. And we want to look into these abnormalities as best we can. The 3D benching model, which the first of several models, was used to test the 3D printer by having it print at odd angles, do complete arches, as well as overhangs. And it did all this without supports. The minimal surface eggs were printed without supports as well. And this was to test how both materials were able to handle the strange overhangs prominent in these models as well, but also to test bed adhesion, which seemed to be a very key part of how this durability and strength of both the composite and non-composite PLA. The all-in-one 3D printer test is the final model that was tested. It provided qualitative results to the angles and tested each part of the 3D model printing process. Now, we are going to look at these models really quickly And after that, we'll have questions. All right, so now we've got our 3D printed models here. We got 2 benchies and 2 minimal space eggs of the same type, I may mention. Yes, we did have a bad failure, and I'll get to that. But here we have the benchy models. These both printed out very well. There was one small thing of filament on inside the carbon fiber PLA, but besides that, there was no stringing, and I believe that this was due to the carbon fiber filament operating at a much higher temperature, which prevented it from cooling down too much to get that stringing effect. Over here, with the standard PLA, we had that stringing effect. Not bad, but still quite a considerable difference. I do believe that not only was it the higher temperature, but the fact that the carbon fiber, since it seems like it has more adherence, and we'll get to that in a bit, that it was able to prevent that stringing by just coalescing together than rather becoming a liquid. It was able to hold itself together compared to just stringing. All right. Besides that, now we have the eggs. We can see with this carbon fiber PLA egg, not glossy, that on the bottom there is quite a few problems with the filament. Of course, this is to be expected because we did not use supports, but it's very small. You get very small patches here. And you can see on the underside of the eggs all those little patches, but not as bad as over here, where you can see that they're long. It's very much more noticeable. Even one of the adhesive parts were lost during this. Not very good, and that loss is most likely what led to this, where it got knocked off the bed. The printer, it does not automatically account for the egg moving, and it just continues to print like so. And you can also see here that it is also incredibly stringy, incredibly, well, not incredibly flexy because it was kind of cooked, but you can see that there is a lot more flex in this than, say, with the carbon fiber, which I found to be kind of tough, very not forgiving there. Um, all right, but yeah, those are the 3D models. All right, here we are for questions. If you need anything to ask, now's the time. All right, have a good one. Thank you for your time.